Hello. So today we are doing this problem called lemonade change, problem number 860. So the problem says that we have a lemonade stand, and each lemonade costs us $5, and we have customers that are standing in a queue, and each one of them orders one at a time with a specific set of bills. These bills are $5, $10, and $20. And we must provide the correct change to each customer so that they don't pay more than $5. And we don't have any change at the start, so only the change that customers bring in are the ones that we have. And we need to return true if we can serve each customer and pay him or her the correct change. So, for example, here the customers, remember, are standing in a queue, so in order. So here, for example, we get $5, $5, and then a customer comes. Because $5, there is no change to return back, so it's always good. And then 10 happens. A customer gives us 10. We need to give them 5. And since we already have 5, we can give that. And then 20, 1 give us 20. And we already have 10 and 2 5s left. So we can just return 1 10 and 1 5. And so this here we can serve all customers and give them the correct change. So this one is correct. For example, this one though, first customer gives us 10. We don't have a 5 to give them back, so it's false. So this is the idea. Now let's look at how can we solve this problem. So this problem, we can solve it by just simulating the exact scenario and seeing if we can exit with giving each customer back the correct change. And so let's just count the number of 5 and 10 that we have. Basically, so just keep track of that. And then we can go through, we could check 20s, but we won't need that. Because for 20, if we have 20, we can't give that as a change to anyone. And so it's not useful to keep track of. But 5 and 10 are useful because if a customer gives us 20, we can give them back 10. So it's useful for us to know how many 10s we have. And same thing with 5. If a customer gives us 10 and we have a 5, we can give them back 5. And so it's useful to know that, to know how many 5s we have. And so here we could just enumerate all the cases. So we can either have the bill equal to 5, or it can be equal to 10, or it can be equal to 20. Those are the 3 cases that we have. And then we are going to check each case. Now, for this case, there's nothing to check. We got 5. We don't need to return anything. So we just keep track of the number of 5s that we have, which increase it by 1. Now, if we get 10, then we need to check if you have no 5s at all, we can't give back 5 as a change. And so we can't serve that customer, basically. And so we need to return false right away. Otherwise, we need to, if we have 5, then at that point we know we have 1 more 10. So let's just keep track of that. And we know we have 1 less 5 since we would need to return that 5 to the customer. So we have 1 less 5. Now let's deal with the case where the bill is equal to 20. Now if we have more than, we have at least 1 10, so more than 0 10, then we can, so 20 is basically can be divided as 20 plus 5 and then 5, but this 5 is what the customer pays, so we don't need to keep track, but we need to give the customer 5 and the 10. And so if we find that we have more than 0 10, that means we can give them back 10. And we need at least a 5 to give back. So also we need 5 to be bigger than 0. So if this is the case, then we give a 5, so we have 10 minus 1. We give a 10, sorry, so we have 10 minus 1. And we give a 5, so we have 5 minus 1. The other case is if we don't have 10, but we have like 5, 5, then we can give to the customer back 5, 5, and then 3, 5, sorry. And so if the number of 5 is bigger than 2, that means we can just give the customer back 3 5s, and we have 3, 5. And then with the left we keep, basically. Now, if it's neither of these cases, for 20, if we don't have these 1 10 and like 1 5, or we don't have more or equal than 3 5, then we can't serve this customer, so we need to return false. Now, if no like case where we can't serve the customer happened for all the bills, that means we can serve all of them, so we can just return true in that case. One thing to note is this kind of solution, whether you are just doing the scenario of the problem and going through it all and seeing if you find the solution, it's called simulation. And yeah, it's a useful idea to keep in mind. Sometimes there is no algorithms, that is just simulating the exact scenario that will happen. Okay, so this solution passes. We can adjust it slightly to make it less verbose, and that would be by doing the following. So we can still keep this enumeration here. We'll just change this slightly. So if the bill is 10, then we can just go ahead right away and say that now we definitely need to return back 5, like there is no other option. And then we need to we have one more 10. But since we are doing this without checking that we have we have at least 1 5, then we need here at the end to check if at the end of this iteration 5 is less than 0. Maybe because here it was 0, for example, then we need to return false, because that means we couldn't serve a customer, basically, or we couldn't give a customer the correct change. Now, for bill equal to 10, equal to so if the bill is equal to 20, in this case, here we don't need to check if the bill equals 20, because if it's not 5 and not 10, then it's certainly 20. But 20 has multiple cases. So if the number of 10 is bigger than 0, then we could just give a customer a 10 and a 5. So in that case, we would have 1 less 5. And 1 less 10. Otherwise, the case where 10 is equal to 0 and the bill is 20, in that case, we can just give back 3 5 to the customer and keep just 1 5. So that's this. So here you notice we just don't check, and we just subtract and then at the end see if we have an illegal case. This is also a useful trick to reduce the number of statements. Don't do a lot of checks, just go ahead and then at the end check if you have an illegal situation, a situation that shouldn't be, and then in that case handle that. So let's run this. Okay, so this also passes. Yeah, and that's it for now. See you. Bye.